Hello, everyone. Thanks for hopping on right at the top of the hour. People are still rapidly joining, so I'm going to give folks about a minute to hop on and get situated, and then we will get started. So thanks so much for your patience. Hey, about 30 more seconds. People are joining slower and slower. Let's let the last few on, and then we will get started. Thanks again for your patience. Okay, let's get going. Welcome to today's Postgres World webinar, Enhancing pgLogical with Multi-Master Features. We're joined by Hassan Hadi, Director of Support and Services at pgEdge, and Katie Motika, Software Engineer at pgEdge. And they're going to discuss handling asynchronous replication with conflict-free delta apply columns, hard to say, replicating partition tables between multiple nodes across regions to address geo-sharding, data residency, and compliance and privacy regulations, and simplifying database system management through seamless integration, enhanced monitoring, and rigorous testing to ensure reliability of your critical systems. My name is Lindsay Hooper. I'm one of the Postgres World organizers, and I will be your host for today's webinar. I want to go through just a little bit of housekeeping, and then we will get started. So the first is that all attendees are on mute to avoid background noise and to preserve audio quality. We recommend putting Zoom on speaker side-by-side mode so that you can see everyone as they're speaking. The second is, yes, we are recording this webinar, and it's going to be accessible on the Postgres conference website by early next week. And finally, my favorite is that questions are encouraged. They're going to be answered throughout the session through the Q&A function in Zoom. You can probably find that at the top or the bottom of your screen. And then today, we are so lucky to have co-founder CTO Dennis Lucier, co-founder and CEO Philip Merrick, and customer success evangelist Hari Kiran on the line to answer your questions as they come in. So don't be shy, get those questions in, and that's all from me. With that, I'm going to hand it off. You can take it away, Hassan.
Yeah, thank you, Lindsay. In this webinar, welcome to the webinar. In this webinar, we're going to talk about the enhancements that are added on top of pgLogical for supporting multi-master replication and bidirectional replication. pgLogical is an open source extension that provides the multi-master, the logical replication capabilities. So my name is Hassan Hadi. I'm the Director of Support and Services with pgEdge. pgEdge provides distributed PostgreSQL that provides multi-active replication support, supported on multiple cloud and also on in-house development. I have been working with databases for more than 20 years. And out of those 20 years, 15 plus years, I've been working with PostgreSQL and as part of the PostgreSQL community. During that time, I also worked with different Postgres companies in various engineering and management roles. Katie, do you want to introduce yourself?
Yeah. Hi, everyone. I'm Katie Motika, a software engineer here at pgEdge, and I've got about 10 years experience working with Postgres.
Thanks, Katie. So in this webinar, we're going to start off with talking about pgLogical extension and talk about some of the functionality and limitation. Then we'll talk about pgEdge and the open source extension from pgEdge that provides support for asynchronous multi-master application. We'll talk about some of the game-changing capabilities provided for fully enabling asynchronous multi-master replication. We'll talk about some unique capabilities added by pgEdge for supporting data residency and supporting distributed application. This will be followed by a short demo by my colleague Katie for showcasing some of those capabilities. So starting with pgLogical, as you all know, is an open source extension that basically provides the ability that provides the ability to do logical replication. pgLogical so pgLogical is an open source extension that provides the logical replication capabilities, and it also has support for bidirectional replication. So bidirectional replication is basically replication between two or more PostgreSQL nodes that are replicating bidirectionally. So this feature is available in pgLogical, but it's missing the conflict resolution capability. So conflict resolution is actually a very key capability that is required in a bidirectional replication support. Without this, it makes this feature really error prone and not very useful. So this is available. Bidirectional replication is available in pgLogical, but without the conflict resolution, which doesn't make it very useful. pgLogical also has the replication filtering capability. So the replication filtering can be done both at the provider level and at the subscriber level. At the provider level, you can basically use the replication filter parameter in order to actually basically filter the data. It's a regular Postgres expression that we can use at the provider level to actually limit the number of rows that is returned by the provider. On the subscriber side, you can also use replication filtering by using the before trigger mechanism. So one key point to note here is that pgLogical is a solution for logical replication, right? So it's inherently not dependent on physical replication. So basically it operates on a higher logical structure, which basically focuses on the data contents and data objects instead of block level storage. Right. So significance of logical replication in Postgres environment. So as you know that PostgreSQL has evolved in Postgres in last number of years, right? With some of the building blocks of logical replication was added in PostgreSQL 9.4, right? Over time, the logical replication feature was actually added in PostgreSQL 10, but the building blocks were started adding from Postgres 9.4. With the passage of time, the logical replication feature has really evolved and has become more mature, and is now deemed as the most advanced and preferred way of application in PostgreSQL. Lots of features have gone into logical replication since 9.4. And some of the features that went into Postgres 16 were being able to apply changes at the subscriber node in parallel. This is a performance feature, being able to basically do the initial table copy in parallel mode, logical decoding on the standby, which makes standby become subscriber to other providers, and then origin filtering, which was kind of a basis for bidirectional replication. So lots of enhancements have been added to logical replication in PostgreSQL, and pgEdge, as explained earlier, pgEdge basically provides fully distributed PostgreSQL, right, cluster, which is optimized for the network edge and provides reduced latency. And it also provides reduced latency and also fulfills the requirements for data residency, as well as provide ultra high availability. Spock is an extension that is released, that is an open source extension from pgEdge, which basically adds functionality on top of pgLogical and VDR, which extends the capabilities for multi-master application that we'll be talking about, in the next slides. The Spock extension, as I mentioned, added significant new functionality on top of the pgLogical extension, which makes which makes the logical replication feature very robust, and which makes it more fault tolerant and more robust and more powerful and more enterprise ready for for dealing with intense workloads. The conflict management feature that is added as part of the Spock extension, it actually enables the simultaneous acceptance of write on multiple nodes. So remember, we talked about bidirectional replication, in which you can have two or more PostgreSQL nodes that are replicating bidirectionally. So without the conflict management feature, you cannot actually have that support. So Spock actually adds the conflict management feature that basically enables bidirectional application and allows basically enables simultaneous acceptance of writes on multiple nodes. So for a minute, let's just talk quickly about what a conflict is. So conflict can arise in a multi-master environment when the same data is modified on multiple nodes. So you can think of basically when a subscriber is subscribed to multiple providers, or you can think of this as a subscriber making updates to its local database, and the conflict arises when there is incoming changes. So when a conflict arises, this needs to be handled. I want to give you a quick example. You can think of a retail company that's basically using a multi-master bidirectional replication to manage manage the inventory of its products that are shared across two different stores. So you have store A and store B, both have their local databases connected with bidirectional replication. And imagine a scenario when an inventory of a product is updated at the same time, right? So both local nodes of the store's databases update the same inventory, and this causes conflict that needs to be handled. So when a conflict occurs, you need to obviously handle it. In Spock extension, we provide different configuration parameters that we can use in order to actually handle the conflicts, right? So in case of a conflict, you can decide whether you want to error out or stop replication, or whether you want to keep local, or you want to have the last update when. So there are multiple configuration that are provided by Spock in order to basically handle, basically do the conflict resolution. So this is actually a really important feature that is part of the Spock extension from pgEdge. And with the asynchronous multi-master replication support, combined with better error handling, conflict management, it basically makes the whole cluster really performant, fault tolerant, and the scalability, with the geo-sharding features that we'll talk about in the next slide. It actually makes it more scalable. So this is obviously very this logical replication enhancements that are provided by Spock and pgEdge are make it really demanding for high intense environment, with high intense workloads. So this is a unique and exciting feature that's provided by the Spock extension. This is basically conflict-free delta column, right? This is also known as conflict avoidance feature, right? And this basically is a powerful yet very simple feature that allows the users to add delta columns to the tables, right? So the delta columns are created with the log old value parameter enabled. And when an update occurs on a delta column, it uses the delta algorithm to actually fix the problem and update the column with the correct value. So think of an example of a bank in which we are basically trying to update the balance, right? So in this case, the conflict avoidance feature can be really critical to ensure that the correct balance is applied when there is when there are when the same account is updated from different nodes. So the conflict avoidance feature is a really powerful feature, and it actually really helps really helps TPCC like environments benchmarks that are highly conflicting workloads. So this actually fills a really big gap in pgLogical, because as you can think that for environments like TPCC workload, which are highly conflicting environments, this actually makes the automatic handling of conflict, avoiding the conflict, can actually make the system very performant, and this really helps the data inconsistency and basically data integrity. And it also ensures the data access times for your application by using bidirectional replication and one-click support. This is actually particularly ideal for developers and administrator, right? Because with the multi-master bidirectional setup, with the conflict avoidance feature, these sort of issues which would normally be handled by DBAs and administrators in a manual fashion, will actually be handled in an automated fashion by using the conflict avoidance feature. So this is actually a really simple yet powerful feature that's provided by Spock. So in this slide, we are going to talk about some extended replication functionality that is provided by pgEdge. So data residency basically means that in certain cases, we need to keep certain data in certain geographical locations, right? This is due to security reasons and legal reasons and other regulatory reasons. So in pgEdge platform, the user can define which tables are replicated globally and which tables are kept locally, right? So, with the ability to decide which tables are replicated globally and which tables are kept locally, we can actually fulfill the requirement of data residency. And this is actually very well supplemented with the geo sharding features that are provided by the Spock extension, right? So in the Spock extension, the user can choose a data location both vertically and horizontally, right? So, you can decide where your data is located, either based on the table column, or based on the row level, right? So, for example, you can actually have tables that are broken based on location, for example, column like country, right? So, so the geo sharding feature can really, be useful in being able to handle, the distributed application. Another cool feature that's provided by the pgEdge platform is the out-of-box support for replication of partition table, right? So this also is really supportive with the geo sharding use case, right, where you can actually automatically replicate your partition tables across your multi-master cluster, right? Replication tables are added to the replication set, and you can add more partition to the partition table, or you can remove existing partition, and those will all be handled automatically by the functionality that's provided by the extension out of the box, right? The row level filtering support is also supported for partition tables, and you can even add normal just single partitions to the replication set as well, but in that case it will be treated like a regular partition, right? So with all the functionality that is provided by pgEdge, with the multi-master asynchronous multi-master capabilities, with config management, with fault tolerance, with the better error handling, better management, it actually makes the data consistent, right? Increases the data consistency and integrity, and being able to keep the data close to the user really helps with minimizing the latency, right? So this is a really important performance feature. By basically keeping the data close to the user, really minimizes the latency. And then the last point is, the pgEdge platform ensures that we are compliant with the PII, which is personally identifiable information. So this basically corresponds to data that can potentially be used for identifying an individual, right? So the organization needs to consider the data residency requirements in this case, and this ties into the data residency requirements and the features provided by pgEdge, where you can basically keep the local data local. So these are some of the extended functionality for multi-master application and bidirectional application provided by the pgEdge platform. So with that, I'm going to hand it over to my colleague Katie to give a short demo in basically demonstrating some of these capabilities.
Thank you. While we're switching over the screen, if anyone participating right now has any questions, there should be a Q&A button at the bottom of your Zoom window where you'd be able to ask us any questions that you have. Okay. What I was going to demonstrate today is a little bit of the global PII situation. So I've got a small data set called Northwind in two nodes. One is in US West 1, and the other node is in EU West 1 or 3. I forget which one it is. So for this example, I'm using the employees table. If any employee is located in the US on the United States node, this US West 1, I do have like the city information and the home phone number information, but I'm not able to see that same PII information for any employee that's from the UK. Similarly, if I go to the UK node and spell Northwind correctly and make that same select statement, you'll be able to see that the UK employees here have their PII information filled out, and the USA employees do not have that PII information on this database. What I'm doing for the multi-master replication is setting up two separate replication sets, and the replication set's going to hold the information about what tables should be replicated from this US node to the EU node and vice versa. So what I've done is created a US replication set that says for this Northwind employees table, going between the US and the US nodes, I'm going to replicate everything for the employees table. But for replication between the US and EU, I'm only going to replicate the ID, the last name, the first name, and all of these other fields that are not classified as PII. So in this list of columns that are replicated, you're not going to see the city and you're not going to see the home phone. So what I will be able to do now is take an example. I'm going to use employee number 1 and pretend that they are changing their phone number. So on the EU node, you get no information for the phone number. On the US node, you've got this one right here. On this US node, I'm going to update the phone number to end with 555. And you can see that that does update the data on the US node, but then when you go over the EU node, it's not going to replicate that personally identifiable information. So you still have the record of that employee, all of the non-PII fields you could do reporting on. Before that information that you've decided cannot go between these two nodes, it's updatable, you can insert whatever, but it's not going to replicate those PII fields that aren't included in this replication set here. On the opposite side, say you had a column that is
Kate,
not, sorry?
so sorry to interrupt you. As you're switching between these tabs, we're only seeing the one on the far left. So when you click on the one in the middle and on the one on the right, we haven't been able to see it.
Okay. This is working now, correct?
Beautiful. Yes. Thank you so much.
Okay. I think what I have on the screen here would fill that in then. This was the update happening to the employees table where that phone number did change. Going over to the EU node, you could see that that phone number stayed null before and after that update because that PII column was not part of the replication set. So apologies for that. And just to go back here also, this is the view of the entire table on the EU node that shows the PII for the UK node, but not for the US employees. Okay, now that you'll be able to see both screens, this next example will be much easier to follow. I'm taking this column, the title, that is not considered part of the PII columns that we've decided on. So on both the US node and on the UK node, you're able to see that this employee number 5 is a sales manager. The home phone number is only available on the UK side and not available on the US side. So saying that this employee got a promotion, and on the EU node, you're going to update that position to a senior sales manager. You could see on the US node, the senior sales manager information did replicate between the two nodes. The PII fields continued to stay null where they're supposed to be. And you're able to interact with the tables on any nodes, but limit what data is going to be available in which country. Ooh, that was everything for the demo. I'm going to hand it over to Dennis and Hari if there are any questions.
Is this the spot where people can raise their hand and ask questions live?
No, I think are we going to go over some of the questions that have already been asked through the QA button and talk in a little bit more detail on them? Or
Okay, there is a question that just came in that specifically has to do with the way you demoed. And it says, is the home phone for PK1 not writable in EU? So just kind of talking a little about what you were showing there and what some of the options are.
Yeah, I haven't done an example where it's not writable in the different countries. So right now, if you were to update on another country, it would be that value on that node and never replicate to the other side. I'm not exactly positive about protections that you could have so that that would not be writable on the node that it's outside of.
Right. So you know, to add a little more flavor to that, it's like we have to be careful of what rules we enforce, because we don't see a full picture. Like at Spock only sees like what came in SQL and what rules are configured. So if you right, there are more advanced things, there are things your application can do, there are things you can do in triggers, right? And we don't make the decisions for you, right? You do simple configuration commands and you tell us which fields you want to protect and which ones you want to keep in country. And that kind of protection can happen at the column level, like we're showing there, or you can do that at the filtered row level or at an entire partition if it's a partition table. So there's a lot of flexibility there. Katie just showed one small demo and she answered exactly how she has that demo configured. So you can probably do what you're looking to do, but her demo was kept simple for everybody's protection, including my own. All right, so if we got a few minutes and people want to stick around, whoever, there's a couple of other interesting questions asked. One is Spock open source? Spock is community licensed, so it's technically not like OSI approved open source, but it is fully open source. It is fully usable by end customers, which would be everybody except for the public cloud providers themselves, right? You can use it on a public cloud, you can use it in your private cloud, you can do what you want with it in development, production, unlimited usage. The only restriction with our community license that makes it not OSI approved is that and this is becoming popular amongst open source software providers, that the public cloud providers can't like just decide to give away our stuff for free and support it without partnering with us, right? We of course want them to do that, and we'll work on being able to do that and interacting with their offerings. But you know, we're open, but we are not a charity in that regard. Ooh, there's a new question. Question is, what happens when failover triggers in nodes? Does the node data replicate between other region nodes for read queries? It's like, yes. So one of the things that happens is, first up, there's flexibility in how you set this up. But by default, when we set up a multi-region active cluster, and you're not setting it up hierarchically, like node, let's say there's 3 nodes. Node 1's changes forward to node 2 and to node 3. Node 2's changes forward to 1 and 3. So there, and node 3, of course, you know, changes forward to 1 and 2. So it's kept up to date asynchronously, and the config resolution kicks in. So that replication is asynchronous. One question that might come to mind is like, well, what if, you know, node 2 fails and node 1 got some of its changes asynchronously and node 3 got more of its changes asynchronously? In those situations, we are working on a go live algorithm and are very close right now. It's working in development that will make sure if node 2 has gone away and it isn't coming back in a timely fashion, any transactions that it sent to node 3 can forward them on to node 1, so that you do have active, very low latency between the nodes, assuming that you had enough network bandwidth to handle the updates you're making. But you are safe with your transactions in that if they've been committed to one region, you can be very comfortable that it's getting to other regions. We also support like synchronous replicas within a region, so that if you want ultra high availability, even, you know, so when if a region, the primary went down, it would switch to the read replica, and that is a synchronous read replica if you configure it that way, so that you really don't lose transactions even though you have active globally. And I either answered that question, over answered it, or confused everybody. I'm sorry.
Dennis, are there any questions that you answered in the Q&A chat that you think would be really good to highlight for everyone?
Yeah. Harry answered one of the questions that I liked that was about, well, people explained to me what PHI stands for. Connection pooler. So connection pooler is an interesting question. The connection pooler itself is not part of Spock. That's part of our pgEdge platform offering and cloud offering, where we like to configure pgcat by default in front of the database server to serve as a throttling mechanism, to serve as a filtering mechanism, and to maintain it so that stateless applications can connect and disconnect very quickly because they're stateless. So the connection is logical. So we like pgLogical. We're big fans of pgBouncer. I'm sorry, we like pgLogical. We do like pgLogical also, but that's not the question. We like pgcat, and we're big fans of its efficiency and its compatibility with pgBouncer, which is why we like pgBouncer. And in the future, as in very early next year in production, we plan to support some other features of pgcat, like its built-in sharding, etc. So you can do everything you can do with pgcat, you can do with our product. It's a question of whether we're doing enhanced value add. So that's one of the things that we're able to do. It's like if you're using pgcat and you're doing sharding with it, it's like we don't stop you from doing that. We question of how much extra features and hand-holding we do in that process, and error handling, etc. So hopefully that talks about, like, yes, we do support a connection pooler by default, and we do use pgcat in front of our platform product. If you decided you don't want to use pgcat, you want to use something else, you wouldn't have to use our default, right? We try to keep it such that it's like, this is Postgres with Spock. And you still have the flexibility. We try to use the best of breed solutions that we can configure nicely for various customers' needs. Ooh, a new open question. Should all writes to a cluster be done through a pool, or is it okay to have an application client connect directly to a single database server? The application client can connect directly to a single database server. It does not have to go through the pooler. Sometimes, you know, if you're running this application, right, you may decide that you're only going to leave port 5433 open, so the application is always going to have to go through the pooler, right? So there is no limitation that we force you to do that. I like and usually do that for applications that I've done in the past, present, and will do in the future. But it isn't a strict requirement that you always go through the pooler. That answers your question that just came in from Mr. Burkholder live. So I like questions. I like to be providing answers that people care about the question. Is Spock. So one of the beauties of logical replication in general, and this is true of pgLogical and logical replication in Postgres in general, it operates on a per database level. Now, that means if you have two databases and you want it on both of them, you just got to enable it on both of them, right? That's absolutely fine. It's flexible. Whereas like a physical streaming replication and some features of that require that it be on the whole cluster, right? Because there's only one Postgres wall. So you do configure logical replication. We try to leave you all that raw power and put training wheels on it, so it's easy for you to use. But we're not taking away any core features where you can really be very fine-grained in how you configure it and what you include and exclude, et cetera. So because it's logical replication, it operates on the database level, but you can also get very in terms of what rows you filter, what tables you actually do, how you do things exactly. So there's a lot of flexibility there with logical replication, and we try to make the most common use cases really easy and provide you with extra error handling and things like that, so that if you're going to do an advanced case, we make that really more approachable for you as well. Very excited to see another open question. What about being available in cloud providers' own services like AWS and GCP? Excellent question indeed. We aim to, so because frankly, I've been the product manager for AWS Postgres, so I'm very familiar with this question. Because they get that from all vendors, like have that for Timescale DB and other things. So we want them to include our product. We want them to partner with us. We just want to be, included in the deal. So because right now Spock is written in C, it's very efficient, and we have to partner with them for them to want to do it. So that's open. They could do it, but we're restricting them by license because much as we all love open source at pgEdge, most of us, including myself, need to get paid. So we want to offer professional support, and we don't want them to offer professional support on it without, disintermediating us because our product is so nice to support that they've decided not to pay us. So we want to work with it. There's always partnership opportunities that I'm pursuing. I know very well the product managers of AWS, Postgres, and GCP, and even Azure at Microsoft, and we're talking to them about possibilities. But right now, the Spock extension itself can run on various flavors of Postgres, but you can't install it as an extension on the service provider's internal stuff. So there's various ways you can interact with that database if you want to kind of, just be logically replicating from that database into a cluster that we handle, et cetera. And we very well support AWS and GCP and Azure, as well as we support hybrid environments where you're doing potentially mixing those if that's what you want, and potentially having some things that are available, in a private data center that is run by Equinix for you, or whatever. So we do strive to do as much as we can in this area and be doing even more in the future. But our hands are a little bit tied in getting AWS to offer it because we didn't give it to them for zero. So that hopefully answers that question, and why we do that, right? It's becoming sort of a common strategy amongst open source providers that, typically you had two choices. You either make it open source completely, or you make it proprietary, right? You do like, hey, our basic stuff is open source, but our advanced features are proprietary. It's like, we chose not to do that model. A more modern model says all of our stuff that we do that runs on any of your database service is fully community licensed, it's fully visible, and you can run it in production without us if you're a customer. And we think that's better. We think that's more attractive for many, if not most customers, than going with a proprietary model for advanced features. There's a good question. Can you mix architectures between ARM64 and x86? We support ARM64 very, very well. In fact, I love that platform on a personal basis. We also support x86 64. And yes, you can mix them, right? It is logical replication. And the transactions are coming over mixed in their logical transactions. So although I've never personally done that, because it's logical, I'm virtually positive we support that. But that's a good check to me to double check that yes is the answer to that question. And I'm pretty sure it is.
Brilliant, Dennis. Thank you so much. I think we probably have time for one more question if there's anything else you'd like to highlight. And then I will wrap us up.
Sure. And Mr. Burkholder has just asked another excellent question. Will low load applications perform satisfactorily on 100 millisecond networks? Absolutely, right? 100 milliseconds, about how much time it takes for packets to round trip between the East Coast of the US and the West Coast. Same thing with the East Coast to like Western Europe. So absolutely, we're designed to work well with various levels of latency, right? So that's why it's asynchronous. And that's why you get instant writes on the region that you're writing to. So it works really well when you combine with modern application development frameworks like Cloudflare, where it's like, it's going to route you to the closest host that's available. So you can do some really cool things, and you're going to get instant performance because it's coming back right away from that host. And then, yes, it can survive 100 millisecond latencies. Things always work better with less latency, but ours is designed to be active in each region. So each region works really, really well, should usually handle most, if not all, of the traffic from that region. And therefore you get excellent latency on everybody. And you can see appropriate things globally in as quickly as your network latency and throughput will allow for it. So we definitely test with different levels, not only different levels of latency between the servers and regions, but are testing real things on AWS and other providers. And you're testing with different packet loss between the regions and stuff like that. So part of the hardening that we've done is to make this work in real network situations. There are situations, I'm not trying to badmouth pgLogical because I like the people that wrote it, and I like it as a baseline for what we've built on. But there are situations where the network is kind of there, but it's unreliable, where pgLogical will lock up, and like the ever ready bunny, we will just keep running. So there's a few situations like that where we've hardened and enhanced. So yes, lower latency is better, but in the real world, we're not able to do anything about the speed of light problem for a global application. Anything else? Thank you for many people to stay and listen to my ranting and raving. And as I said, you can reach out to us at an individual level and ask questions that you don't want to ask in front of the group. We're glad to chit chat. Lindsay, you want to take over?
Yeah, I'll take us out. So, Dennis, thank you for taking the time. It's not every day you have a CTO co-founder who hops on to handle Q&A. So I really appreciate your time. Hari, thank you so much for also handling Q&A. Katie, Asan, best in the game. Thank you so much for your time, for your effort here. And to all of our attendees, thank you so much for spending part of your day with us. So whether it's morning, afternoon, or evening, no matter where you are, I hope you have a great rest of your day. This recording will be live by early next week on our website if you'd like to revisit it. And I hope to see you on future PostgreSQL webinars. Cheers.